All right, it's July 6th, and we've already had many interesting topics come onto the table. So I guess working towards some of the more focal work with what George has previously written stuff. So Shingai, maybe what did you think about this message?
What this made me think is that this kind of captures for me why it is important to have more programs in system science, to have system science widely accepted as a legitimate academic discipline, because if we can frame it as a sort of, the new liberal arts, a interdisciplinary foundation from which anyone can be a lifelong learner and learn to build and engage with various types of systems, then it won't be the case that only, as David says, software engineers are like the only people who are like capable of thinking systemically. So yeah, I don't know, I see a very obvious need to make it exciting and accessible for more people to think and act systemically. And system science programs would be a great way to help make that happen.
Awesome, thank you. This is sort of like people even mention, now this person may be familiar with different systems. Low likelihood that they've read George's book, but high likelihood that they will have been familiar with the concept of a system. Computer systems, platforms and protocols as systems, just like, but it's even in a mass appeal communication. It's just interesting to see how systems are, this is the last line. And this is like the so just this framing. Now, if 5,781 people decided to engage in a system science program, you know, where do you go after seeing this message? Well, right now would be become a software engineer, because why not?
Mm-hmm.
But then, like, helping see that there's a substrate that describes this and that we can pull back to, and also be a software engineer. Like, that's the window and that's the opportunity. Carl or George, anything else just on this, or we'll continue on?
I really can't think of anything. I just, it's kind of interesting, this tweet. So I mean, I taught computer science and software engineering as part of that, and watched it go through the evolution from, basically writing little bits of code and then putting them together to try to get some larger functionality, to the object-oriented programming methods that emerged. And I could see very clearly in that that emergence, the honest to goodness systems thinking that was going on behind it. Whether the people, I can't even remember the guy's name now, but the people who were pushing that program forward were clearly thinking systemically. And anyway, yeah.
Interesting. A side note is that I tried to learn programming through taking Java at Stanford, and I like really struggled. But once I was introduced to Python and the object-oriented framework, it all of a sudden clicked, and I found myself able to get into it. So yeah, I don't know.
Yeah, it's kind of ironic in a way that Java was really, there was C++, and Java came out roughly around the same time, and they were object oriented. But both of them were incredibly complicated to get started with. And the reason was they were developed to support software engineering, but you already had to know the concepts of software engineering in order to use them, meaningfully. Python came along, and originally it was not object oriented as such. And so, but it was so flexible. So it has the capacity to do just about anything. And so they were able to then put that object-oriented framework into the thing and make it accessible, make it easy to understand what was going on. So Python's kind of taken over as the language of choice. It works for web development, everything.
Yeah. And my father and I have probably been involved in the two biggest boondoggle there is. My dad was working on IB&V for the air traffic control system they tried to start building in the early 80s, and they were using Ada, and then there was a Rational actually had built a machine that, so he had hardware that was like almost dedicated to the Ada environment and stuff. My boondoggle is not as related to this topic, but it's the it's called the integrated acquisition environment, that there were 14 IT systems that are how people do business with the government, and they were trying to bring 14 systems into one, and they started that in 2001, and I think they've really only got one piece of it completed now.
That's literally the XKCD comic.
Sam.gov was the
Okay, just a few thoughts on that. First off, can software engineers build and maintain enduring systems? That's the precariousness, is actually that it's not the whole picture. And so it's actually not the case that just by having a certain professional title that you actually are building these reliable enduring systems. One approach, Shingai, that might be useful with the SysXML would be, I mean, if you think about it at levels of abstraction, one option is it's a program within Python. It's a Python program, or it's then the next level would be it's a package that has other programs. Then it's a eventually it could be a system-oriented programming paradigm. And maybe George has even described it as such. But it's like, okay, so we have like the assembly code from category theory. We know about this object through its morphisms and everything. So if we can write the right assembly code, we can implement this category theoretic notion of object. Now we have object-oriented programming. If we want system as object, that's the tuple in George's specification. We're talking about not just an object-oriented program. That's like sort of a, but that's the right direction. But ultimately, even that, to be really embodied, would have to be its own systems-oriented paradigm of programming. It's like, no, this is a level of abstraction to engage in. You don't need to worry about allocating the RAM sector. That's the C++. Then the object and defining your variables in Python, what we know of as modern programming. And then there's another level of abstraction and execution that would be supported with a systems orientation. What do you think about that, George?
Yeah, my idea behind SysXML and the XML part is to try to marry up in a much more, well, in a systems framework, the descriptive aspects and the functional aspects. So the programming, normally, you write a Python program, you're writing something to perform some function. The description is sort of inherent in the background, but it's not made explicit. So the idea here was to make this accessible, like a markup language. I mean, so many people could learn, HTML without, and they really understood what it was they were doing because they were describing what a page would look like. And then along comes, they started embedding scripting language within HTML to give it some functionality and so forth, but they never were designed to be together from the beginning. They just had to, kind of add stuff in to get it to work the way we came to know and love. So that was really, and then the fact that it starts from the perspective of systemness, not just objectness, but systemness in its entirety was the goal that I had in mind.
That's awesome. Thank you. And to connect that to the kind of liberal arts question, if we start with object, then we end up, I mean, not just in atomization and all of this, but if you start with object and nihilism, etc. So it's like, then you're going to have all these questions about what about when objects relate to each other? Often provided as an alternative to object-based thinking is process-based thinking or functional. But that's its own dialectic. Obviously, system encompasses both of those. So instead of having like a object versus process tug of war, take it in the right direction with systems properties. But current programming languages, they pick a lane. Either they are object oriented or process oriented, but there's no scaffold for them to have been in both lanes. So engineering decisions had to be made.
Yeah, with Java and C++, you could see this tension because once you described an object, and that was a descriptive process of doing it, then you had to look inside the object and say, well, what's this object going to do? And there you had to go back to process-oriented programming. And the hardest thing I ever found was getting students to understand the kind of relation that and you always had to break, some rule in order to get done what you really wanted to get done in the first place. I taught students object-oriented programming using C, not C++, C. Basically, I started out to try to show them how C++ implemented, because the original C++ compiler was actually just a pre-compiler or pre-processor for C programs. So, and it would generate C program, which then could be compiled and made into a runnable program. Yeah, so that problem has existed sort of right from the get-go, and the systems orientation, I think it gets resolved.
Yeah, so I just have a clarifying question. I'm wondering if it's useful to think of systems language as a new programming language that will be based in this systems paradigm that is sort of an alternative to object-oriented and process-oriented. So you have a new language based in a new paradigm. And like once that paradigm is fleshed out, it could be adopted by other programming languages. Yeah, is that a useful framework or not quite right?
Yeah, I never really saw, well, the better model perhaps is system dynamics with, with Stella or whatever. Because this was an attempt to combine both descriptive and process in one framework, and it was a systems framework. I think it was incomplete. It was good for what it did, but it wasn't. It didn't have the fullness of systemness in it. And so nobody, I don't think, ever really looked at SD as a alternative programming language. You wouldn't try to build the Denver airport baggage handling system out of an SD language. But yeah, I just what got me started and along these lines was actually attempting to build a couple of more realistic systems model in the energy what am I trying to say, production arena, trying to model not just a solar energy system and how much energy it would produce, but how much energy would it have to produce to reproduce itself, kind of thing. And I found none of at that time SD languages, Stella being the main one at that time, had the expressiveness that I needed. The model was getting to be way more complicated than I felt it needed to be. And so I started thinking about this approach to descriptive language that would use those system, from the get-go, system-based icons, but there will be enough of them, like the flow, not just the flows and stocks and flows and controls, but basically all of the other elements that would be needed to fully describe a system as system. And so that's how that got started, Shanghai. And I think the paradigm is a systemness. It's the idea that you're constructing a system, not an object. You're constructing a system, not just a program. Does that clarify a little bit?
Yeah.
Thanks, George. This is really helpful. But this is a kind of a ladder that we can reach towards. First, we write a SysXML program. Well, this isn't the timeline. This isn't the timeline, but this is just the order of abstraction. SysXML could be a program written in a language, which kind of like, it's like the like cutting the Gordian knot of the object-oriented would be like using the object-oriented paradigm language and then being able to express systemness and one useful tool might be the category theory methods in Julia. Writing the specification of SysXML, which is more or less what we've been talking about, but that would be phrased in analytic formalisms, just like the textbook did, but maybe a little bit more operationalized, so that it could then be written in Julia or Rust or Python, leaving open what a language would be, or maybe this would essentially requires its own internal language. And then systemness as the paradigm and the guiding moral, just like object orientation. Everyone understood, okay, we're orienting to objects. That's our stance. That's what we want to facilitate: articulation of objects, transferring of objects, message queues of objects. Everyone kind of understood like the big picture of that software ecosystem. But then systemness could similarly be the organizing mode, whether it was implemented as program, package, or language.
Yeah, that's a really helpful framing. And I think it's exciting because if the programs written in this approach work and they work well, then people will want to adopt the paradigm. So I feel like I have focused a lot on, trying to explain the philosophy and persuade people that this is the right way to see the world. But if you can give people like a tool that allows them to build useful systems, then yeah, that might get the job done a bit more effectively.
Remembering that the other sort of half of the equation is the analytic front end, that that whatever, yeah. And so I envisioned writing, if I were younger, I'd probably be doing it, writing that front end in a graphical user interface with drag and drop. We've talked about these ideas, but it would be a guide. It would still insist the syntax, the underlying syntax would say, no, you can't plug that flow into something that isn't an interface. It's got to go into an interface. It can't just go anywhere in the subsystem, or that you've got to follow the rules. It's like a law of thermodynamics. You've got to make sure you've got a balanced system, so on and so forth. So that part would, in essence, kind of force the issue of systemness, and then the balance of the back end is the code that you generate that simulates that system, which is ultimately, sort of what the researcher or practitioner is going to want to do.
Awesome. I always think of this as the triple play: graphical visualization, natural language, executable cognitive simulation. Like when you move a graphical thing, the other two would be updated, and that includes the simulation being a valid program. And when you change something in the program, like they all should be in the same way, and having integrity amongst those. To say nothing of the kind of like of how different implementing that kind of system would be. There's the technical work to relate the pieces. But this is, I think, very good progress in how we're thinking about it. Just to kind of fuse with another piece that came up earlier. Unless, Carl, do you want to add anything from some of the notes that you've shared, if you want?
I just posted some links and stuff. As kind of what I talked about before was like secondhand from decades ago. So I put some links into more about this IBM rational rows and UML. And then I also put in a link. There's a object-oriented user experience kind of group that that could get into what George was just talking about, having the user interface piece of it. So
that sounds good. Also, I think UML, like real UML has never been tried because it's not centering systemsness. So yeah, you can specify the model descriptively, but if you were able to describe the systemness of the system of interest, you would have already written it in SysXML and systemese. So clearly unified modeling languages are just like sort of a shadow or a kind of precursor to integrated systems modeling, but an important precursor because it puts the syntax on the same page. But then it doesn't go further than that, right? Or how would you relate SysXML to UML?
Well, UML, I abandoned it long time ago. Not long after we got fully into the object-oriented. And the reason is because, yes, it did describe the structure of whatever you were trying to develop. And it captured relations, and it really was a good thinking tool for the time. But when it came to then, moving over and saying, all right, now we're going to write this in Java or C++, there was a disconnect. And what you said earlier, Daniel, is exactly right. If you change one thing, like if you were to change, well, SysML is a little bit better because it does describe function, within the model itself. But in what I had observed was people would go and do these very elaborate UML diagrams and try to capture all the relations they could and so forth. And bear in mind, that was without that kind of front end guidance, right? This was all coming out of somebody's mind without having any sort of overall framework that they were working on. Now, since then, of course, we've gotten all kinds of model-based design approaches because we've looked at all of our so-called best practices and tried to say, now, if you're trying to accomplish this, this is the model you want to use, and that's the best guidance we can give you at this time. But yeah, UML. I just, I don't know, at some point I stopped doing it. And I really started with my students. I started them drawing circles and flows and all that kind of stuff, because I found that much more relevant to the kinds of, we were always doing simulation modeling and things of that nature. So anyhow.
Yeah, well, good work, George. It brings us to where we need to be, I believe. And a lot of other pieces are now better in place, like not the least of which, potentially CAD as a systems execution framework, and active inference and everything in that domain to help us have the flexibility to describe cyber-physical systems at different scales, cognitive systems too. And the more recent, yeah, all these different things that we've talked about in the past. But I wanted to kind of bring it to the analytic autoethnography question. In a sense, that is what the ISSS education group does. Carl, would you agree or reflect on that?
Could you restate that last part again? Just to...
In what ways, or just how similar, or however you feel, this very group and what we do in ISSS education groups and the conversations that we have, would that all be considered, or how do you consider that as analytic autoethnography?
Yeah, I think it's certainly closer to, and then there's actually also a collaborative autoethnography. Um, um, yeah, I'll track down the source, but yeah, there's like, I've got a book that's like, there's like 3 women, they're all at the same university.
Just while you're, the
And
reason
then
why I, oh,
and then
sorry.
there's also Cynthia Kurtz. I actually met her at ISSS 20 last year and stuff, and she's written participatory narrative inquiry, things which I also think it could tie into that. And she's got, I was just on her website, and it talks about having a project-oriented kind of thing. So maybe we could have a cohort that would look at kind of working with her to kind of go through a particular project.
I have another colleague who has brought up this area. The reason why I asked such a blatantly leading question, never never asked the question you don't know the answer to, but I mean, is it not the analytic philosophical approach to reading in between the citations, getting George's perspectives, like on equations and on then this is where it becomes the collaborative part, I believe, like and what the whole, I have a conversation with this historical figure is like, another way to think about that is give a new prompt to the ethnographical system of interest, but in real time while we're all here, that is the collaborative autoethnography. And then you could think about that as having 2 flavors or a continuum. The shared experience, like the phenomenology and the mental health and the cultural component, like how are we doing? What does it feel like to be our group? That is all good and valid. It can be very qualitative and navel gazing, like, whereas the analytic approach and operationalism, pragmatism, all this, but the analytic approach actually structures how we ask those questions. Like, let's ask questions to this person while they're here so that future ethnographers wouldn't say, why was this asked, not that? But making the right decision in the collaborative moment. But that opens up like a million unfoldings. Like, I just think about Bucky Fuller and William Blake, whose I guess you could say ethnographic works I'm most familiar with. But Blake was very internal, private. Bucky was very out there. And then another level of being out there is being real-time unfolding in the moment. Where as new technologies appear, it's like we can get so much new information, and that's a lot like probing a system and continuing to get new information from a quantum system as it works. I think it's going to get some of these things recorded because I think they're very important topics.
Yeah, the what I was discovering this was a couple years ago that I was writing some papers, but yeah, I mean, there's the whole like quantifying qualitative, you know, looking at that type of thing. So yeah, I mean, that I kind of joke about somebody else's dissertation. If I really got into that, that could probably be an EDD, but that's got to wait. But there's so much there as you've been like describing. I mean, it's I don't know how a lot of this stuff is fairly new. Like I think that book was 2019.
Yes, cognitive science, studying heterogeneous, diverse cognitive ecosystems has, or at least relative to a better standard, has failed to become multi or inter or transdisciplinary because cognitive systems are systems. The real good research agenda is and would have been to have pursued system science and understand cognitive systems as systems and all that that inherits. And it would have only been a positive direction and relationship between cognitive science and system science.
Yeah, it would have been interesting to be at CogSci 2019 because that Nunes article, I guess, had just come out a month or two before, and it dominated the conversation. As I said, I mean, there must have been some really heated conversations there. And then
yeah, so this is the analytic autoethnography. They were basically saying that they're coming to the cognitive science field and saying like, hey, we need to be critical of our own, you know, perspective. Is that what happened?
That seems to be what happened. As I said, I discovered these two, and I've had them flagged to kind of get back to, but I'm still I gotta narrow down my scope and stuff. So save it for postdoc and stuff. So trying to get the piece I'm trying to carve out.
Yes, of course. Friston missing. Tragic. How could it be in 2019 and the most cited neuroscientist of all time? Don't worry about it. It's unreal. That's the meta sociology on Friston, free energy principle, active, which is hand in glove with systems science, I believe.
Yeah, the meeting I was in at 11 this morning, people were talking about the perceptron or whatever, Marvin Minsky and Peart, and how it really set back, really looking at neural networks for probably 10 to 15 years is what the person was talking about. But
well, there are a couple of trends that set back neural networks.
yeah,
quite a while. And I mean, as an engineering tool, what we have today with the so-called fully connected networks and learning rules like backpropagation and so forth, they do a certain amount of work for us. Like they're good at categorization, pattern recognition, that kind of thing. But I still maintain, I mean, all my PhD work was looking at how real neurons specifically or particularly the synaptic junctions worked in terms of the dynamics of encoding information and associations, how they made causal associations. And, you know, I can construct a reasonable approximation of Bayesian network that's more like what, the way a brain, or at least parts of a brain, would work. And I knew Rummelhart. Yeah, I was right there in San Diego. I met with the guy on a number of occasions, and we talked about this. And he insisted that no, they're going to find one day, they're going to find that this is how our brains work. This fully connected network thing. It'll be in layers, but that whole paradigm. And that was before they had discovered face neurons and things of that nature. Anyway, I don't mean to go off on that.
Of course, everyone, is doing what they can do. So all good for everything that happened. That being said, no measurement should be a setback when we have a system science view. If we have our system of interest, we're a quantum cognitive agent, we're getting information from the classical screen, nothing should be a setback. At worst, it's irrelevant, and we just don't pay attention to it. But I think it reflects the sociology, why something can be a setback. And that's why a bigger picture has to happen, because these things are not just technical problems. It's like the catch-22 and the simultaneous bootstrapping. But I think we the qualitative environment for systemness as a paradigm to arise is here. And the other half that needs to be brought out more clearly and developed is the analytical approach on systemsness, which is its own synthetic work reflected in the textbook. But just, I think a lot of these pieces connect well, so that that's encouraging. And we can lay things out and just work on it incrementally. Let's see where it talks about systems. Symbolic systems. I remember a lot of colleagues in there in Stanford. The field is defined as the study of intelligence and intelligent systems. It's right. It's all in the name. Nervous system as part of the organism as system. We'd expect it to be reflected in systematic ways. Okay, well, the departments are just going to fight for funding and attention. The systematic way is system science. No field is systematically present in the core requirements. Couldn't ask for a better setup. That's right. Because system science should be the program at the bachelor's level. You could just go on and on. Every single usage of this term, we know why. But also we think it could be better. But it's cool that they did the bibliographic analysis to show this kind of, it's because if you go out there in the interdisciplinary gray zone, you're not going to find institutional or potentially even social support. SFI was able to bootstrap itself into providing institutional support for complexity in the gray zone and all of that. But a similar type of initiative is required, which is why Shinkai's brought up SFI. We've talked about these things before. Nice. Thanks for posting it, Shinkai. Is there a missing dark field? That's one way to say it. Or another would be, this is a classical screen 2-dimension projection from the quantum space. And so it's not about just what's in the middle of this dot on the projection. It's about rotating it upwards into a higher dimension and just having this higher dimensional object where people are part of the picture, computer science is part of the picture. But it's not about like X marks the spot on this. It's about the higher dimensional object and then all the perspectives and the ways of knowing and working that we can have with that higher object. But this is the next step. So thank you, fellows. Very fun. Shingai, I'm sure we have many things we could work on and distill, but appreciate all the emails to George and the information sent. Let's continue to work on it. Anyone else have any closing thoughts?
No, I'm good.
That's great.
Sure. Did you grab that? I've had the link to Cynthia's page, and she has this PNI practicum thing. So I was thinking maybe we can talk with her, and maybe there could be something that we set up.
All right. Let's revisit that next time.
Yeah. One final thought. I was looking into like a list of candidate systems that would be good to like start analyzing. And I think it could be useful to have a chat about that before the next education meeting. So I don't know, Daniel or George, if you guys have any time next week, but I would love to share my thoughts over like a list of potential systems that would be well suited to showing like how this process of deep systems analysis would actually be useful.
Yeah, so one more thing I just remembered. Tyler Volk and Lynn Rasmussen and I are going to be getting together over Zoom to start discussing some details about, he wrote about what he called combogenesis, and I write about what I call ontogenesis. And we've known for years that we're talking the same thing. We have never really pinned it down, so we want to start doing that. And I think that will tie into what you're looking for, Shingai, and because what we want to do is start. His book was called Quarks to Culture, and we want to start at a very fundamental quantum level and describe the systemness of protons, for example, or the systemness of atoms. And so we would be using the same basic approach. So
cool.
We've been discussing this back and forth for quite a while. At some point, I think probably we'll want to expand and bring more people into it and so forth. But that's what's going on in the background.
Okay, very cool.
Thank you. Best of luck, everybody. See you next time.
Bye-bye.